Hey guys, this is the result of the Portal VFX that I created entirely in Houdini. I rendered that in Redshift and composited that in Nuke. That's the result, and let's analyze the render passes inside the Nuke. And after that we are going to back to Houdini and see how I create each layer. That's the final result inside the Nuke. That's the compositing. Let's see each layer and how I approach the construction of each layer inside Houdini. The first layer is just a reflection geometry border. Let's see this in play. Just like a liquid noisy reflected to create the middle. This part here. This middle part here in liquid, high contrast. I create some masks here. You can see an RGB UV mask. Fall off from outside inside. I'll reverse the fall off. And a top down fall off. The next layer just a simple particle simulation. Another layer of particles. A big layer of particle effects, like a small sparks, another sparks here, slow velocity sparks, the ground light itself, just a single frame for because we don't have any camera animation, I just render one frame for that. That's like a fractal created in noise. Okay. And another pass here, like a fractal fluid noise. There's a translate here in UV and some time animation in the noise. I will show that in a second in Houdini. And another mask layer here. With the same approach of this mask here. Just like an RGB. Fall off from outside inside. Reverse the fall off. And top, bottom to up fall off. Now let's go back to Houdini and I will show how to create each passes. The first geometry we need to create here is this core shape setup here. Let's dive inside. The result of this shape is like this. Just a fractal circle noise with some UVs here. The creation, I start with a circle at the middle. Then I poly extrude that, just the border. And I extrude just the border. And I clip the backside. I organize the vertex order of the points because we need that just to correct the UVs. I create a group selection from these 3 points here. 1, 2, 3. And I just keep that points. Sort the points in Y. Change the order here. Because we need to create it back again that spline. I transform a little bit the point 2. And I construct that. Because we need UVs. We don't have any UVs here. And I use that transformation, the revolve, just to construct the back of the UVs. I poly bevel these edges here. And I promote the UVs from vertex to points. I adjust the scale a little bit, stretch in Y. I lift the circle to align with the ground. Add the subdivision noise here. Then I use a little Vex script, you can see here, just to create a mask in the ramp of U direction. A gradient from white to black in U direction, just to create the fall off here. I implement some noise. Let's disable here the specular. The first pass of noise. Then I smooth a little bit this noise, subdivide again, more 3 times to create a more resolution geometry. And I use the same node of the Vex script, just to change the gradient ramp here. I reverse that because the polygons is from back face. Reapply the normals and create another pass of noise, fractal noise. Another pass, more turbulence noise here, from the middle, the inside. This is just a checkpoint for other passes. I clip the ground here. Let's see if background different background color. We don't need the ground. Delete all the attributes that we don't need. And create the fall off from the bottom to upside. Just this pass of color here, we are going to use in the Nuke for the compositing. And create a name here. That's the result of the first pass. Let's see the second pass. The result of this pass is here. This is just a border, outside border, to create some rays here. This border created this rays in that pass. That's the pass we are going to use in this geometry here. Let's see from the beginning. First we need to import the Fractal Portal and use some Vex script here just to remove, based on the UVX, some geometry that we don't need. For example, if you enable here, you can see like a clip, but this clip is created in UV. You can change here, like the cropping the geometry based on the UVX. I use the labs node extract the borders just to extract the start and the final border. Delete all the attributes, delete all the groups, and make a cache. The cache is just to avoid the processing of these nodes before. And I fuse all the nodes, convert to the line, and delete the back line we don't need. We just need the front line. I resample this line. Actually, I resample this line just to get this attribute, curve UV attribute. We don't need to change the topology, we just need the curve UV. I use a sort to organize by vertex order, and I shift the PT none just to make the first point near from the bottom side. This transforming node we are not using, we can disable that. Here, just scale a little bit, scale and stretch in the x-axis, and I align that with the middle of this, the center of the main shape here. I created the UVs, uniform spline here, smooth the outline a little bit, freeze the time frame, give it a little bit more noise, create an attribute here. UVX should be 1, UVY should be curve U. And here I create again the texture for this small polyline, create the vex, UVX should be 0, UVY should be curve U. I smooth the polyline a little bit and merge the two lines. Here, I copy these lines and create a blend shape curves. What I did here inside this subnet, just to separate the first line, create a for each node for number and 10 times, and I create a blend shape in each iteration. The blend shape for this, the second input, the small polyline for the first input, and that's the result of the for each loop with 10 iterations. Then I transform the curves a little bit. Simply I just grab the reference to see where I can move transform these points. First, I move this to front. Then I move the first line a little bit back and the second polyline a little bit. Actually, this node we don't need to use. Can disable that. I use attribute promote the UVs to point to vertex. I skin that geometry. You can see here all the lines, just the polylines in skin. Create like a mask noise. Let's visualize this mask. I create a mask noise like a fall off from the UVs. I promote that mask from vertex to point. I create another subdivide. Add a little bit of noise. Use the name to apply the shaders. I clip the bottom. I just create a ramp of colors from the bottom to the up, just to create a mask inside the shaders, to use it as alpha blending inside the Nuke. Here I create the alpha bottom attribute, just to use the color, delete all the attributes we don't need, just keep the CD, curve U and mask. And I smooth the geometry. That's the output. Let's see the particles and how I create that. The bottom particles was this layer here in the Nuke. That's the bottom particles. Let's see how I approach the effects. I just import again the Fractal portal. Clip the top because we are going to emit just from the bottom side. Subdivide a little bit. Create like a fractal mask using VOPs. Inside this VOP mask, we are not using that. Let's organize these nodes. First, I grab the UV, apply some ramp here, and I grab the position, apply the turbulence noise, fit the range to -1 to 1, and create another ramp, multiply, and go back to the color. That's the mask we need. I adjust the color a little bit in the top, because we don't need to emit the sharp edge here. We just need to create a simple fall off. I delete the UV attributes. We don't need the UV anymore here. And I create a centroid of velocity. Here, let's see the velocity field. The point velocity. The point velocity used is start from this point here. And I create this vex script here just to create a velocity vector based on this centroid point here. I grab the centroid point from this input and I create these attributes ampvel. I normalize the position of each vertex from the centroid point, and then I multiply the velocity by the luminance of the color and apply some addition here by 1. Then I send that to the particle simulation. Let's dive inside. Just import the source here. Emission attribute should be the color, because we don't need to emit from the out geometry. We just need to emit from the color, from these white areas here. Apply a pop force with amplitude, surreal size, and apply some alpha based on age. Delete the attributes we don't need, like alpha and ID. Delete the groups, and that it's our particles. From the bottom, we compute velocity, adjust the alpha a little bit, random by ID, change the color to green, delete the ID attributes we don't need, that's the bottom particles. Another pass of particles here is bottle sparks. In Nuke, bottle sparks is this layer here. Just like a small particles, sparks from the bottom. The result here in Houdini is this. Let's see how I approach the construction. Just import again the fractal noise, fractal portal. Clip the top, clip the ground, apply some color here in the bounding box Y. Subdivide one pass. Use the same mask noise from the bottle particles. This is the same construction here, the same node. Adjust the color again from the top. Delete the attribute we don't need, like UV, and make the velocity again using the same script and the same centroid. That's the velocity direction. Using the point velocity just to animate the velocity using curl noise. Inside the particles, the structure is the same from the bottom particles. Just source using the attribute emission CD. Apply the same pop force and the same pop color using alpha by any age. Before the cache, we delete some attributes we don't need and just keep the alpha and ID. Delete all the groups, and that's the result of the caching. We compute the velocity by ID, create a particle trail, and create this adjust attribute, adjust float, to make the particles different size, different length from each other. Now guys, let's see how I create the velocity field from these particles here. The resulting simulation from these particles. This particle here. This particle here. And this particle here. Let's see the setup in Houdini. First, I create the volume simulation to drive the particles using the velocity field. That's the volume simulation. Let's in play. It's like a little bit slow to read the caching. Let's see from the beginning. I import again the fractal border, fractal portal, using some wax here to remove the black edges here we don't need. Extract again the borders. Fuse the borders. Actually, we can see here there's two borders. Convert this to line and make a cache. That's the result. Delete the back spline we don't need. Delete all the attributes. Create a rest attribute. Center the spline with the word. and create a velocity vector here, like this. The velocity vectors point outwards. Just with simple script, velocity equals normalize of p. Move the spline back again to the top using the rest structure rest. Resample that to make the subdivision curves with more points. Create an attribute color here, because we just need this animated mask in the red areas to emit the points. And create a checkpoint here. Increase the velocity a little bit, create a more chaotic velocity. You can scale the velocity using Vex. Just make the turbulence noise with fit and multiply by some amplitude. Here, we are going to use this in the particle B. We are just create some script here to make the velocity bigger in the bottom areas here. Apply some attribute noise and color the red to white. Here, using the age by bounding Y, we are going to send this attribute age here, life, to the particle simulation to make the particles at the top 3 seconds age life span in the bottom and less than a second in the top. Create a checkpoint. Delete all the attributes. Create a sweep node. Smooth these edges a little bit. Create a parallel source. You use the attribute noise to change the density. Like this. You can see the density in the emitter. Attribute noise to the temperature. Should be different. Then I attribute transfer the velocity. Grab the velocity here, use this Vex script. Using the attribute transfer. Increase the chaos of the point noise, the point velocity. And rasterize the density, the velocity, and the temperature. Create a parallel source here. With some global substeps too. Ground collision. Using the density. You are not using the burn, but we are using the velocity. Dissipation here should be a pretty slow value. And that's the result of the caching. We are interested here just in this velocity. In this velocity field here, we are not using the density to emit any particles, just use the velocity of the smoke to drive the particles in the particle simulation. That's the velocity field. Here, we are going to use a bounding box, create a velocity field ambient, just to make the particles move in the noise a little bit after escape from the velocity field of the smoke. We freeze the frame here. Create a bound. Create a points from volume here. Create some random point velocity. And convert this to VDB. That's the volume with the velocity field. We are going to use this velocity field inside the particle simulations. The first simulation, just pretty simple. Just the simulation from the edges with the short lifespan. We imported just the outline. Make the scale of the velocity different. With noise. Create more position noise here. We are going to create a lifespan attribute based on the Y direction. We need, for example, in the result, we can see here the bottom particles have more lifespan than the top. Here in the bottom is 2 seconds. In the top I think is less than 1 second. Using this VFX script here. The particle simulation is pretty simple. Like a source to emit a lot of particles. In the emission attribute color, using pop color just to update the alpha based on any age. A simple pop force using some VFX. Another layer of pop force and some pop drag here just to avoid the particles escape from the fast velocity. After the cache, we just use the trail to compute velocity using by ID attribute. That's the first layer of particles using velocity. The second layer of particles using velocity. That's the big one. Here in the Nuke, we can see. That's the big particle. We are going to analyze that. Again, just use the outline. Inside the particle simulation, just pretty simple, the source. With life expense of 2. Emission attribute CD. Using pop color just to drive the alpha based on the age. Now we are going to use the pop advect by volumes, using that smoke velocity field to drive the particle's velocity and try to follow the shape of the volume simulation. And a little bit of the pop force. Before the cache, we deleted some attributes we don't need, just keep the alpha, ID and age, delete all the groups, and that's the result of the particles. We have here in the bottom, we have a lot of lifespan. At the top, we have short-lived particles. And here, we fade a little bit the core, just to avoid this sharp transition here from the beginning. And create an emission by age attributes using VFX. And again, compute the velocity of the particles based on the ID attribute. The last particle here is just the small sparks. Let's see the result. We just import again the outline with the mask, delete all the attributes except the CD, life and life var, create a sweep with a small thickness. Inside the particle simulation, just the same particle simulation from the big particles, a source with the life expense of 2. Just a source, pop colors to drive the alpha here, pop advect by volumes to drive the just to drive the velocity of the particles, try to follow the shape of the smoke simulation, and the pop drag. We are not using the VFX expression, just the pop drag. After the cache, we compute the velocity based on ID of the particles. Add some p-scale to rendering, p-scale like 0.1, and create a particle trail just to make the particles with length like sparks, and that's the result. Now we are going to see the rendering. To render that, I just create a render layers here just to reference the output here inside these nodes, or we can directly import this direct to Solaris, doesn't matter, just for organization. Because I want to organize this like a render layers and just the nodes of setup. Here inside the LOP network, let's see by the order. First I just created the basic camera and I export that to USD to be reusable in the other networks. I create the first layer, just I create a simple ground, using the render geometry settings to disable the alpha. Import the core shape, just to make the shadow on the grounds. The core shape doesn't have the primary ray visible, and I reference the camera and apply some shaders here. After the shaders, just a point light here in the middle and the Redshift node. Inside the material, just the simple color, just the default material with high roughness and the black color. Just the default ground with some light colors and the cast shadow of the portal. This particle noise, just import again the core shape, the result here. That's the portal fractal. Here, just create the material, assign the material, reference the camera. We put some R lights in the backside and a dome light within some AGRI file. The shader, just a maximum noise with some convert this to HSV. Color splitter just to make the one channel here. Make a ramp just to make more purplish. And apply that to standard material. And that's it. This doesn't have the displacement because the geometry is already displaced by attribute noise in the soft level. These particles here, just the bottom particles. Here using render geometry settings just to enable the velocity blur. Reference the camera using the same dome light. Inside the materials, you're using the CD, which is called the display color in Solaris. Using the same display opacity for create the incandescent. Just a simple shader. We are going to use the same shader for this bottle sparks with the same camera and the same light. Let's see the render. Okay, actually this shader is white. Let me see what is happening. I think I just applied the white shader, the white color to the geometry. Not problem. You change that in comp. And here, let's see the particles, the geometry. That's the fluid noise. Reference the camera. Get our fractal border. Apply some fractal noise here. That's the shader. Using apply to the UV. And make the incandescent material. The next shade just a UV pass. Using just apply the colors based on the UV, red, green and blue. Another pass here, border raise mask. That's just the fractal noise here. RS noise. With some color ramp. Some exponent and apply to incandescent in the color. You're using the UV map, color splitter, a ramp here, multiplied by the alpha borrow because we don't need to be sharp in bottom here, we can create a little fall off here. For example here, if you want to see what is happening in this stretch, because the noise is a stretch. Let's see the noise without the stretching. That's the original noise without the stretch. We are stretching here in the Y15 and the scaling X 0.2. We are using the simple RS noise just to make the stretch raise here. And the portal mask. Just import the camera, import the core shape with noise, apply some shaders to UV, and create 3 channels of fall off: red, green, and blue. The shader is pretty simple. Just import the UV map here, color splitter. Multiply this by the display color. Now the three last one passes, just the particles. Here just import the camera. All the three particles from volume are using the same shader. The shader is pretty simple. Just import the display opacity or alpha. Create a ramp from that, or green ramp, and the color mix the emission with the opacity, and apply this to color and create a ramp and apply this to alpha. That's the result of the first pass. That outline pass, that one here. The second pass is the big one, the big particle simulation. And the last one, the small one, just the sparks. That's it for the rendering. Let's see the composite right now. That's the result of the compositing. Let's see how I create that network inside the Nuke. Let's see the output. That's the result. Let's start from the beginning here. First, we just read the portal beauty. And here just the portal mask within this RGB fall off for each channel. First I shuffle the first channel, grade a little bit because we just need the fall off from the beauty here. Let's see. Without the fall off, just the sharp transition, we don't want that. I increase the grade, there's no problem, but I create the fall off from the inside and use the shuffle in another channel. I ramp this with using grade to make the fall off from the outside. That's the start, and that's the multiply with the both masks. I color correct a little bit to make more purple. And I read the bottom particles. Change the color using hue shift. Using the grade to make purple. Clamp out the non-pixels here. And I using the merge plus just to merge the particles with the geometry here, the portal. Let's see another particle pass. That's the particle from volume small. Apply some hue shift here. Color correct to make more purple. Color grade to increase the purple. Clamp the non-pixels and add that to the composite using merge plus. Another pass here. That's the big particle simulation. Apply our hue shift here just to change to purple. Apply color correction, a grade to make this just the purple. Apply the glow and merge with the over mode. There's like the sparks from volume. Apply a hue shift here, color correct to make purple, and then clamp out the non-pixels. That's the result. Like a little sparks here. The body sparks. Apply some hue. Color correction to make more red. Color grade to change the red to purple. Clamp out the non-pixels. And apply the merge to the main comp. You can see here. The fractal portal. Border race. Apply some glow. Color grade to make it bluish. Color correct to contrast a little bit. Clamp out the pixels. and merge with the main comp. You can see the rays here in the blue. Now just the ground. Color grade to make purple. Clamp the pixels and add with the main comp. Now just the last layer. This fractal layer here, fractal mask. We create a mask tool to make the fall off the inside border and outside border and a little bit in the bottom. We shuffle the X, fall off inside, G, fall off outside, and blue to fall off the bottom. And I multiply to the fractal layer. This is the original layer and this after the multiplication here. Color grade to make purple. Color correct to increase the contrast and increase the gamma. Make the glow. Clamp the pixels and merge to the main comp. That's the result without the color correction. And you create a Redshift to desaturate a little bit. Using a vector field with some LUT here, just to make it more orange. Clamp all the non-pixels. Using a hue shift to make it green. Using the glow a little bit. Using color correct to make more contrast. And grade to increase a little bit the gamma here. And that's the result of our compositing in Nuke. If you want to get the file from the Gumroad, you can use the link in the description and get the file to stud, the complete file in Houdini, Nuke and the renders. Thank you guys. See you at my next video.